Hey, welcome to lesson two, the vector nature of Newton's second law. In other words, Newton's second law in two dimensions. Okay, so let's begin. Here's an example. When a football player throws a pass, the direction of the force and the resulting acceleration are important. The direction of the vectors can be broken down into x and y components. The sum of the forces equals mass times this acceleration in the x direction, and the sum of the forces in the y direction is equal to mass times the acceleration in the y direction. Here's an example question. A man is stranded on a raft. The mass of the man and the raft is 1,300 kilograms. By paddling, he causes an average force P of 17 newtons to be applied to the raft in a direction due east. The wind exerts a force of 15 newtons and points 67 degrees north of east. Find the x and y components of the raft's acceleration. So here we have an example. The person on the raft is paddling to the right in the eastward direction, and the wind is blowing at 67 degrees north of east and has a force of 15 newtons. So this vector here represents the force of the wind, and this vector here represents the paddling that's done by the person on the raft. The paddle is applying a force of 17 newtons directly due east, and the force of the wind can be broken down into x and y components as you see here. Okay, so the x component is A, which represents the force of the air times cos 67, and the y component is A times sine 67. And over here, what we see is the total displacement of the raft after the time that the forces are applied. So we can break up the components, break up the forces into components. The force P is already broken up into the x component because it only has an x component. So the y component is 0. And the force of the air can be broken down into the x component, which is 15 times cos 67, and the y component, which is 15 times sine 67. And then we can simply take the sum of the forces in the x direction and add them together to find the total force. In this case, that's 23 newtons. And in the y direction, it's this simply the force of the air, which is 14 newtons. It's really important to pay attention to signs when you do this breaking down of the x and y components. If the force is negative, then you would have to put in your appropriate negative signs. This is a relatively simple example, and so the forces are all positive. Okay, so note it is important to take into account the direction of the x and y components of the force. If the force points in the negative x or negative y direction, the forces would be negative. Acceleration can be calculated using the equation. Acceleration is equal to the sum of the forces, the net force, divided by mass. And in the x direction, that's equal to positive 23 divided by 1,300, which equals 0.018 meters per second squared. And in the y direction, it's the sum of the forces divided by mass, which equals 14 newtons divided by 1,300 kilograms, which equals 0.011 meters per second squared. At the moment the forces P and A begin acting on the raft in example 2, the velocity of the raft is 0.15 meters per second in a direction due east. Assuming that the forces act for 65 seconds, find the x and y components of the raft's displacement. So at the moment the forces P and A act, the raft is already moving 0.15 meters per second in a direction due east. So that is your Vx initial velocity. So we can find the displacement in the x direction by using the following formula. And we can plug in the values. If I go too fast, just pause the video where you need to and copy down the notes. And that's equal to 48 meters. And we can do the same thing in the y direction. We can find the displacement in the y direction. And plugging in our values. The y direction, v initial in the y direction is just 0. There is no velocity in the y direction initially. And so it's just a simple equation. And we work it out as 23 meters. Diagram D shows the final location of the raft. So over here, this diagram shows the final location of the raft. The final location is right here. You have the x and y components. And you could calculate the displacement by using Pythagoras theorem here to find the total displacement, but it's just asking for the x and y components, so that's all you have to do here. Now you can go ahead and try questions 10 to 13 and question 15 from page 116. I've printed out the questions on the worksheet that follows this presentation. Thank you.